You're going?
Yeah.
Okay. So, sorry, the tape cut off. But you would take this, and by doing this, you'd make an anion here. I want you to think about this. This would come in here, this would open up, and then you'd eliminate it. And when you eliminate it, you would get that structure that I showed you. So in other words, this attacking here is going to kind of merge another ring on here. This is some pretty fancy synthesis, okay? And this is going to be the O-, and the carbonyl is going to be up here. And then if you just protonate this and then cook it some more, you would eliminate it, and you'd end up with that compound. So you could actually build a whole series of rings if you wanted to, using these reactions that you've learned. Now, running out of time, this is like a long review. I wanted to go over like the older stuff and kind of have you revisit it and just rethink that and get like a richer understanding of how all that material is extremely unified, and it's extremely unified with what you learned before. You're not really doing anything new. It's just like a little more sophisticated. I would reiterate, do not forget stereochemistry, okay? In these reactions, if you're making asymmetric carbons, you're going to get all the combinations. And if you're making double bonds, there's a distinct possibility you'll get mostly trans, as we did in the laboratory, but you might get some cis, or you might get some E versus Z situation. Okay. Now, sugars, right? That was the next big thing we did. Sugars, the main thing you need to know how to do is the structural issues. So you need to be able to take a sugar, a linear sugar, what I've called an aldohexose or a ketohexose. Okay, that means aldehyde or ketone. You have to be able to cyclize it, tip it on its side, and draw it in its Haworth formation, which is the ring formation. Okay, as I showed you, use my methodology. Okay, so in other words, always draw D sugars. So always build your structure on this frame. Okay, so if I had some